So finally, we want to get an understanding of parallel and perpendicular lines and their equations. When lines are parallel, that means they never touch one another. That means they'll have the same slope. Vertical lines can be parallel as well, and always are parallel, but we can't say that they have the same slope except to say that they're undefined. So if you have parallel lines, then you'll be able to determine the slope of another line parallel to one given. So here we have an equation of a line given in general form. We want to find the equation of another line that has the same slope because it's parallel and goes through the point 5, 2. So we're going to need to find the slope of the given line, and to do so, we could put it into slope-intercept form. So we would subtract 5 from both sides. Then we would want to get the y alone in slope-intercept form, so subtract 4x from both sides. And finally, to get the y alone, we need to undo the multiplication by 6, so we'll divide everything by 6. So 6y divided by 6 is y. Negative 4x divided by 6 is negative 4/6x, which is negative 2/3 x. And negative 5 divided by 6 is negative 5/6. We can see now that it's in slope-intercept form, y equals mx plus b. M is negative 2/3. So our line, whose equation we're going to find, must also have a slope of negative 2/3. So we can use that slope and that point 5, 2 that goes through this line to determine its equation. I like point slope form. So y minus y1 equals m times the quantity x minus x1. In this case, m is equal to negative 2/3 because it's parallel to the line we were given on the previous slide. x1 is the x coordinate of the point on the line, and y1 is the y coordinate of the point on the line. So notice I have x minus 5 because the x coordinate on our line was 5, and y minus 2 because the y coordinate on our line was 2, on our line. So now I want to get rid of my fraction, so I'm going to multiply through by 3. General form, we need all integer coefficients, so I multiply everything on the left-hand side by 3. And when I multiply the right-hand side by 3, I get just a negative 2 out in front. When I distribute that to x minus 5, negative 2 times x is negative 2x, and negative 2 times negative 5 is positive 10. If we're putting this equation in general form, we prefer that the coefficient of x be positive. So we're going to move the negative 2x to the left-hand side so that it will become positive 2x. We also know it has to be equal to 0, so we'll have to subtract 10 from both sides as well, and negative 6 minus 10 is equal to negative 16. There's the general form of a line that is parallel to the one that we were given and passes through the point 5, 2. When we are wanting to find the equation of a line that's perpendicular, in other words, forms a right angle with a given line, their slopes will be opposite reciprocals. So if one of them has a slope of 1/2, the other will have a slope of negative 2/1 or negative 2. The other way to look at that is that the product of their slopes, m1 and m2, will always equal negative 1. So like my example, 1/2 times negative 2/1, multiply top by top and bottom by bottom, and you get negative 2/2, which is negative 1. So slopes of lines that are perpendicular will be opposite reciprocals, but that also means that when you multiply those slopes together, you get a product of negative 1. So perpendicular lines form a right angle. So here we have 3 vertices of a triangle on the coordinate plane, and we want to determine if this is a right triangle. So are two of those sides perpendicular to one another? If so, then it's a right triangle. So I checked first to see if the side PR and the side QR are perpendicular to one another. So I found the slope of PR by taking R's y-coordinate minus P's y-coordinate, 5 minus 3, over R's x-coordinate minus P's x-coordinate, 11 minus 3. And I get 2/8, which is 1/4. Now I found the slope of line QR. I took R's y-coordinate, 5, minus Q's x-coordinate, 17. Or y-coordinate, excuse me. And then I took R's x-coordinate 11 minus Q's x-coordinate 8. And I got 5 minus 17 is negative 12. Negative 12 over 11 minus 8 would be negative 12 over 3, which is negative 4. Notice that if you multiply 1/4 by negative 4, you get a product of negative 1. Therefore, they are perpendicular. Also, the opposite reciprocal of 1/4 is negative 4 over 1, which is negative 4. If I graphed it, plotting the points P, Q, and R that were given, we can see that that does appear to be a right angle at the vertex R. Now, if you're asked to determine the equation of a line that is perpendicular to one given, say for instance this slide or this example said find the equation of the line that is perpendicular to the given line. We determined that the slope of this line was negative 2/3. So the slope of a line perpendicular to it would be the opposite reciprocal, which would be positive 3/2. And then we could go and use our point slope form to determine the equation of that perpendicular line in the very same way we did here. We're just using a different slope.